this is an exciting example. We want to show you how to answer the question how a function sounds. In addition to the previous example where we started plotting functions, we want to listen to them. Here is our first function. It's basically some sort of sine wave, and this specifies the tone A, and here you see the frequency 440 Hertz is it in this case, and then we have a amplitude of 64, a max amplitude of 64 here, and you could change these values to get different results. We'll come to that later. This is our first basic example. Here in the function evaluator, we want to plot the function, and just a very short part of it, the 10th, no, 1% of a second, and then with very high resolution. And I click invoke here, and here is our function. So now how does the function sound? I click invoke on the sound generator. So this sounds boring, doesn't it? So why don't we add another function to it? So we drag a connection from the second example we have prepared here to the function evaluator. We click invoke on the trajectory plotter, and here is a really exciting one. Actually, these are two tones. It's the A from before, and then another one, and this is E. And those combined sound like this. Still, you can hear two tones, but still it's not so exciting. And this is why we have prepared a nice overtone sample, which changes the frequency. So here you see we have a time-dependent frequency, which is really exciting. First we plot the function. It actually just looks like regular sine function, but if you look closely, then you'll see here there is something that changes the regular sine curve, and let's see how that looks like. Here you can see it clearly, and this comes from the modulo here. And now let's hear how this sounds. So this is really exciting, I think. If you want to teach how sounds are generated, like in synthesizers and stuff like that, or if you want to teach physics and you want to just show how frequencies can be used to generate different kinds of sounds and how it looks from a mathematical perspective, then this is an ideal laboratory that you can use. And many parts are like before, and there's only one special part. This is the sound generator, and we look at the source code. And the really nice thing is here that we just use some classes, some nice classes from the Java runtime, and you'll find some tutorials on the internet, and it'll explain how this actually works. This is where I took the code from, and the really interesting thing is that in VRL-Studio you can just paste that code if it's part of the JDK, and then it will just work. And in this case we have a really nice example of how to access the sound card. And actually this is just roughly 60 lines of code, and this is everything you need. There's no special plugin that you need to access the sound card. So in a way it's even easier than visualizing a function.